Okay, hi class. So we are doing section 1.4, composition of functions. Now, hopefully this is, everyone's seen this before about function composition, okay? And what it means is that when we take two functions, we can combine them. And the way we combine them is called composition. It has this cool symbol right here. The little FOG, the little O means that you're going to compose something. So it's like fog, you know. And the way it works is that the one function that's nearest the x, so the g in this case, you do that first. And so you do g of x first, whatever that is, and then you take that and you put it into f. So it'll be easier to see with an example. If we take these two functions, f and g, okay, this first asking us to do f of g of x. Now what that means is that you do f of whatever g of x is. And g of x, it takes this input and it writes it and it adds 2. So it's going to be x plus 2. And then we take that x plus 2 and we put it into f. Now what does f do? Well, f takes this input and it squares it. So in this case, we're going to get x plus 2 squared, because that's what f does. It takes this input and squares it, and then we'll go ahead and FOIL it out, and we'll get x squared plus 2x plus 2x plus 4, which is equal to x squared plus 4x plus 4. Okay, remember this is FOIL, so over here what I did was x plus 2 times x plus 2, and then you FOIL. So first term is x times x, and outside term is plus 2x, inside term is plus 2x, and last term is plus 4. Okay, now let's take a look at what g of x does. Okay, g of x, what that's going to do, g of f of x, is that it takes f of x, and so that's going to be x squared, and it puts that inside of g. Now again, what does g do? G takes this input, it writes it, so it's going to be x squared, and then it adds 2 to it, so it adds 2. And that's it. Remember, we can't combine these because they're not like terms. Okay? All right. Okay, I'm going to have to erase this, sorry, but I'm just getting, yeah, there you go. Okay, so that's what composition does. It takes an input and plops it into another function. Now remember, order matters. So if I say f of g of x, that's different than g of f of x, okay? And they're very specific. When we do composition, f of g of x, okay, the way I read it is that I say, what's the function that's closest to the x first? And that's actually what I do first. Okay, if I had it as other way, g composed with f of x, then you actually do f of x first. So just remember that order matters. Let's take a look at this example here. I'll let you read it. You can go ahead and pause and read it, and then come back. And okay, we're back. And so what it says is that, let's interpret what c of s of 25 is. Well, remember s of t gives the number of squats a person can complete. So in this case, s is squats, and t is seconds. So the first part, s of 25, that must be 25 seconds. And s of 25, that must mean the number of squats that that person can do in 25 seconds. Okay? So now that we know what s of 25 is, s of 25 is the number of squats in 25 seconds. C of s, remember what c gives us. C gives us calories. And so c of s of 25 brackets there. What that must mean is the number of calories a person burns doing number of squats in 25 seconds. So you can see the function notation is really nice. It's really compact. It says a lot. So if I say C of S of 25, that says this whole sentence. It's the number of calories that the person burns doing the number of squats they can do in 25 seconds. So it's pretty cool. So it's real nice. Let's get practice with this, f of g of 3 and g of f of 3. So remember, order matters. So when it asks us to do g of 3, and here's our inputs, 1, 2, 3, 4, and here's our functions. I don't know what these functions look like. All I know is a table. So it says we want to evaluate g of 3 first. So let's find g of 3. So write that in red. G of 3, remember 3 is the input. So input is right here, x. So I find 3, and then I figure out what g of 3 is. So 2 is equal to g of 3. Okay, so now when I'm doing this problem here, when it wants me to do f of g of 3, I now know that g of 3 is 2, so it's going to be f of 2. And now I just go back to say, okay, so now I know this is 2. Try a different color here. So I go back over to here to 2, and I look at 2, and I say, okay, what is f of x at 2? Well, it's right here. So f of 2 is equal to 8. And so that means that f of 2, our answer, is going to be 8. Okay, so f of g of 3 is equal to 8. And let's do it the other way. Let's do g of f of 3. So, okay, so again, find f of 3 first. Remember, 3 is the input, so 3 is right here. And so I go find f of 3, which is right here. F of 3, oh, is 3. Okay, so this is asking me to find g of f of 3. So I know that's g of 3. Okay? And now that I know I'm looking at g of 3, I go find it as an input, which is right here. And I find out what's g of 3. Well, I already knew what g of 3 was. We did it earlier, and it's 2. So I know that this is equal to 2. So g of f of 3 is equal to 2. Okay, and just go in that manner. Okay, find the inputs first. Remember, the order matters, so do whatever the function is first, the one that's closest to the input there. Okay, so here are two functions with equations. Let's get practice. This asks for f of h of 1. So again, what does that mean? Well, that means take 1 first and plug that in. In this case, it wants to do h first because it's f of h. So we do h first, and so we plug 1 into h. So h of 1 is going to be 3 times 1 plus 2, which is 5. So now when we do f of h of 1, I know what h of 1 is. H of 1 is 5. And so this is just going to be now f of 5. Make sure I'm recording okay. Sounds good? Okay. F of 5. Okay. And so this is our input now, 5. And so we're just going to plug 5 in to wherever we see. So what does f do? F takes in an input, t, and what does it do to it? It squares its input and takes it away. So this is going to become 5 squared minus 5. And that's 25 minus 5, which is 20. So we answered the question, what was f of h of 1? That was 20. Okay. So again, just remember order matters. Do the 1 first, do it into H, and then plug that into F. Okay? So just go step by step. Go ahead and practice. I want you guys to pause the video and practice this. I'm going to write the answer very quickly here with not a lot of explanation, just because I want to see if you guys are doing okay. So go ahead and pause the video and come back and see if you get the answer that I get. Okay, so these are the answers I got. And compare them with yours and see what you got. Just quickly, f of 2 is 2 squared, which is 4. Take away 2, which is 2. So f of 2 is 2, and then you plug 2 into h, and you get 6 plus 2, which is 8. And vice versa, if you go the other way, negative 2, that's going to be negative 2 squared, which is positive 4. So negative 2 squared minus a negative 2. That's equal to 4 plus 2, which is equal to 6. And so I just plugged in h of 6, which is going to be 18 plus 2, which is 20. So that's why I got 20 there. Okay, hopefully you guys got the same thing. If you didn't get the same thing, maybe just check your work and see how I did it, okay? And we're going to be talking about one last thing, which is the domain of a composition, okay? And the domain is, remember the domain, just as a reminder, the definition of domain is the set of all valid inputs. Okay, and remember we have to be careful because inputs could have different variables, but typically it's x, but what it means is what can go into the function OK. And basically remember that means we don't want to divide by 0, and we don't want to take square roots of negative numbers. So when we're finding the domain of a composite function, f of g of x, then we just want to make sure we have to check two things. So basically you have to check the domain of f of g, and you have to check the domain of f. Okay? So anyways, it's probably easiest to do an example, so let me show you how to do it. Okay? So this says let's find the domain of the composition function. So step 1 is just excuse me. Step 1 is just go ahead and compute whatever f of g of x is. So let's do that first. So, all right, step 1, f of g of x. Okay, the way we do that is, again, we take g of x, which is this 4 over 3x minus 2, we plug that into f. So we get f of, let me write it big here, 4 over 3x minus 2. Okay, now that looks worrisome, but remember this is the input now, and so wherever we saw x in f, what does it do to its input? It takes it and it just plots it on the bottom of this fraction. So for us, we're going to have f does this, it takes 5 and it writes its whole thing right here, 4 over 3x minus 2. Again, what does f do? It writes 5, it divides by x minus 1. So we have 5 over the input, and we take away 1. Okay? Alright, so that's the first step. We calculated the composition. I'm going to do some algebra here to make it nice. I'm going to make a common denominator. So we'll have 5 over 4 over 3x minus 2 minus 3x minus 2 over 3x minus 2. So I just got a common denominator there. I multiplied this, try to squeeze it in, but multiply this by 3x minus 2 on top and bottom. And then we just to distribute the negative and see what we get. So we're going to get over here, let me write it right over here. We're going to get 5 over 4, take away 3x, and then negative negative makes a positive 2, all over 3x minus 2. And then we can combine those and we get 5 over 4 plus 2 is 6, so we get 6 minus 3x over 3x minus 2. Okay, we can stop there if we wanted. We can do one more step because this is a compound fraction. So remember, that means that this comes up and it multiplies by the reciprocal of the other guy. So it's 3x minus 2. Let me know if that's totally foreign to y'all, but that's basically what you do if you have a fraction over a fraction. Just flip the bottom one and bring it up and multiply. And then we get 5 over this giant mess, and I'm not going to do any more. I'm just going to leave it. Okay? Not a whole lot more that I really wanted to do on that. Okay. Yeah. Okay. So now we see, if it's okay, I'm going to write this over here. I ran out of room, so I'm going to write what the composition was right here. So it's 5 over 6 minus 3x, 3x minus 2. Okay, and I'm going to have to erase some of this, so make sure that you get it all. Pause the video if you need to and get all this again. But that's our composition right there. And now that I have that, all we do is we just look at, okay, what are the domains that we have now? And so the domain, remember, is going to be all numbers except for the restrictions, and the restriction happened where I divide by 0. So it looks like I could divide by 0 twice here, and so step 2 is just figure out what's the restrictions. For this problem, it means, let's take a look at where am I going to divide by 0. So I can divide by 0 in 2 places. In 2 places. A, it could happen when 6 minus 3x is equal to 0. And B, it could happen when 3x minus 2 equals 0. Because if this were equal to 0, it'd be 0 times something, which would be still divided by 0. If this term were 0, then the whole thing on the bottom would be 0, so it's no good. So we find our 2 answers. This one's going to be 6 equals 3x, which means divide by 3. It means 2 is equal to x. Okay, so that's one answer. And then this one says 3x is equal to 2. Divide by 3, and you get x is equal to 2/3. Okay, so that means our domain is going to be all real numbers. Now it's really easy to say in English. Our domain is going to be, x can be anything except 2 and 2/3. But we can't write that because math people don't like to write a lot of words. So we use the notation that we learned in 1.2, which is that, okay, if I want to say it can be all numbers except 2 and 2/3, the way I write it is negative infinity up to the first number, which is 2/3. Okay, I want to union it with, okay, the interval between these two, 2/3 and 2, and then union it again with 2 to infinity. Let me draw that on a number line to help you, because it's not super obvious why there's 3 intervals. Let me draw it with black. Okay, if I have -1, 0, 1, 2, 3, and remember infinity is over here and negative infinity is over here. the domain is x can't be 2 and x can't be 2/3. So I have a little open dot here, and 2/3 is about right here. So right there, 2/3 and 2. We won't do that. Sorry. Microsoft Word went crazy right there. Okay, back to pins. Okay, 0 and 2/3. So I can be everything on the number line except those two numbers. And you see why there's 3 intervals now? The first interval is -infinity up to 2/3. So that's that first interval. But then I also have to have 2/3 up to 2, which is this interval. So that is right there. And then I have to have 2 to infinity, which is this interval right there. So that's the domain for that. And in general, just do those steps. Find the composition, and then find the new restriction that you started with. I'm sorry, find the restrictions that you are now have from that new problem, the new function that you just made. Okay, I'll post the filled-in notes with. I recommend giving you guys to try to practice these and see if you can do them.